Hi all and welcome back. Today we are continue exploring the other opportunities for steam and boiler system related to the energy saving, and this one is also a very frequent one. We can see it a lot in our cases in most of the industries related to adjusting air to fuel ratio. Actually, this is very important, and as I told you before, we usually take this through the same sequence that for this case study to make it more compelling to you and enable you to do the assessment yourself in order to find opportunities that can help you to develop your business and help your company. We will take it through the typically talking about the opportunity, then the challenge. We will talk about the solution, then we'll take case study to verify this case with numbers to illustrate the case for you. The rule of thumb here that we are following saying that this opportunity that for every 1% increase in excess oxygen in the flue gas from optimum value, this will lead to 1% increase in your fuel consumption. And by the way, this is very huge amount of money and value. Not only 1% when is maybe someone will think is something insignificant, but actually it is significant. This is why we will see in numbers this can lead to thousands and thousands of dollars of saving and wasted amount or opportunity. Okay, so first of all, we can zoom in a little bit here for this graph to talk about the combustion in theory. This is the stoichiometric combustion between any fuel and the air related to that. And on the right hand side, we will increasing the air. On the left hand side, we are decreasing the air. So this is excessive fuel and this is excessive air. Typically, if we are increasing the air, we will find some amount of residual oxygen appearing in the outlets, and we also will notice that the combustion efficiency will drop down. It will reach a peak, then again it will go down because of the amount of air that we are adding is taking from the heat generated by the combustion. This is why we believe the efficiency is going down rather than transferring this heat to the boiler itself. On the left hand side, if we decrease the excess air, we start to see incomplete combustion happening. So we can see some sort of CO appearing, and then we can see some unburned fuel appearing in the outlet. So also this will be associated with the decline of the efficiency dramatically on the left hand side here. Typically, you can say, okay, what is the optimum range? With optimum range, we want to stay here. And if we consider natural gas boilers, which is the most used now in the industry, we're talking about the range between 2 to 3 or 1 to 3% excess oxygen, which is represented by from 10 to 15 or 5 to 15% excess oxygen. This is the optimum range starting from here to the peak. In order to do that in the old boilers, we can see that this was controlled manually, and in most of the recent development and recent installment, we can see this boiler house have its own automatic control. So if we zoom to this graph, we can see all the control loops related to the boiler, and this is the one that I am talking about. Here some analyzer detect the amount of oxygen here and send the feedback signal to the combustion air fan, and this ratio together with the amount of fuel is applied by the main controller according to the load of the boiler, and it was also cascading this with other like the level drum temperature or the superheated steam outlet and desuperheater and other things. So in most of the cases, if your boiler is not equipped with this automatic control, so maybe this is upgrade that you need to make for that. But in the meanwhile, if this will take some time or until we install the system in a proper window, I think we need to share the knowledge with you that this is the optimum range that you are responsible to put your boiler in this range yourself as operator. So what will happen if if the excess air really increase above this limit? As we mentioned, that this will increase the flue gas temperature, and this means that you are wasting amount of heat outside the boiler. Your flame temperature will decrease because amount of sensible heat will be converted to the flue gases rather than conveying this through conduction and convection to the boiler itself. And this for sure will be associated with some sort of financial losses because this is high operating cost that typically any operating company should not be bearing. For the implementation also from the best practice, first of all, we need to check your boiler manual to see what is the correct excess oxygen that you have. And then if you don't have this one by any mean, I think you can refer to this table as a guiding. You will see that the natural gas boilers, the range between 1 to 3, the liquid fuel is 1 to 4, and the same for the coal and the other heavy residual fired boilers. The amount of oxygen need is increasing by that. And then once you decide that this is the oxygen that you have now is much more than the design, you can start slowly decreasing the air to fuel ratio and monitor the amount of oxygen that you have on the outlet. And then take care when you are making this one, you have to make it in a small steps, and then also you need to take care where you put your analyzer probe in order to have a proper measurement for the amount of oxygen that you have. Let's take one case study to see how this really economically reflects on your operating cost. We can use this curve here, or the table that we have here. This is showing you the amount of excess air as a percentage volume, and this is the amount of oxygen that you have as a residue at the end of the day. And you can see this is very linear. When you increase the air, the amount of excess oxygen that we can find on the outlet flue gas is increasing. And this is the difference between the flue gas temperature minus the combustion air temperature. And you can see here also it is increasing. And once this increase happening, you can see that this range here represents the efficiency of the combustion efficiency, or the overall efficiency for your boiler. So for example, if we have the case that we have excess oxygen in the range of 10, and we found the temperature difference between the combustion air and the flue gas temperature is 150, and we managed to decrease the amount of excess oxygen from 10 to 2, I think we can increase the efficiency from 97.3 to 83.1. So let's take one example here, and in our case, based on one true example that we have done ourselves during one of our energy audit to one industry. We found a natural gas boiler during the energy audits, and taking the measurement of excess oxygen in the flue gases, we found this value in the range of 7, and the temperature difference between the flue gas and the combustion air was 205. And this means that this boiler was running with efficiency like 75.6. And the request or the ask that we need to calculate how much annual saving that will happen if we manage to tune the excess air from the amount that they are sending now to in the range of 10% to reach 2% O2 content or 2.3 O2 content. Those are the given, like how many hours this boiler is running. It's 1,500, and it consumes 1.7 almost million BTU of natural gas, and producing 70 tons of medium steam, like 25 bar steam. And the fuel cost in this analysis, this is the governmental value, it is $4.5 per million BTU. So if we go back to our table here, I think if we manage to do that, we found that when we managed to tune this boiler, the amount of air reached to 2 to 2.3 when we measure it, and the amount of difference in the temperature reached 150. So this means that we shifted ourselves from here across that one to this side. So we managed to increase our efficiency from 78.2 to 83.1. And this means that if you want to calculate how much the annual saving, it is the fuel consumption multiplied by 1 minus the difference ratio between the two efficiencies multiplied by the fuel cost. And this will give you about $730,000 or $724,000 per year. And if you converted this to the Egyptian pounds, we are talking about 12.3 million Egyptian pound per year. So assume that this is the effect of doing this manual every now and then, if we manage to keep this in a constant rhythm. But I think in order to sustain this kind of saving, we need to upgrade our boiler control system. So we estimated the cost installing this automatic system or upgrading the boiler control system by $50K. So this opportunity return on investment, if we are convincing our management, we are talking about 1,400% increase in that as a percentage ROI, which is very attractive. And the payback will be about less than 2 months if you do the math and see how much you are repaying back the amount of cost that you are doing here. So in order to see how we are playing the role of that, doing this ourselves as Energia or the other energy service companies. We start from giving you the full spectrum of services, identifying the opportunity, investigate, and then put the system in place, implement the case study itself with the system, and then inspect the results to ensure that we have managed to achieve the overall picture. And we managed, alhamdulillah, to do this with a lot of our partners till now. And we also providing this through some online engineering modules or online courses to our colleagues in order to spread the knowledge. And till now we reach about 500 plus students with 4.5 rating out of 5. And we're still doing this because we believe that together we can save energy for life. And if you believe what you have seen here is really valuable and you need to spread the knowledge, you can help us through sharing this with others. If you believe this is really valuable and this is something that good that you are sharing, and this is really will help us to cascade our message to others and enable you to do whatever analysis that you want to do yourself. We are after the saving, we are not after the business itself, because this is not the case. The case that we really want to save resources to our next generation and really have impact on our lives. Thank you so much, and please advise us if you have any clarification. We are more than happy to reply to that through our web page or Facebook group or our YouTube, if you leave your comment down there. Thank you so much, and see you in the next step. See you.